As you may recall, the scientific method is an iterative step-by-step process that starts with making observations and ends with communicating experimental results. For the most part, the steps work best when you go through them in order: making an observation, asking a scientific question, formulating a valid hypothesis, testing that hypothesis, analyzing the data, drawing conclusions, and then communicating the results to the scientific community. Sometimes, though, you can jump around a bit. For example, if you get to the point where you analyze your data and you realize that something isn't quite right, you can go back to the part where you test your hypothesis and try again. Or maybe you go through the entire process, but during your experimentation you have some new observations that lead you to ask more questions. These questions lead you to new hypotheses that lead you to new experiments, and off you go again. The main idea behind the scientific method is that the steps are connected to each other. They all work together to create good science, and each depends on the other to have any real purpose. For example, think about that near final step, drawing conclusions. The conclusions that you come to are formed not only from your experimental data, but also from your prior knowledge on the topic at hand. This knowledge may have come from the research you did when you formulated your hypothesis, or it may have come from something you studied before. But you can't have logical conclusions about data without actually collecting data and knowing what those data mean. Likewise, scientific observations are great, but if you don't do anything with those observations, they're dead on arrival. However, you have to carefully think about your observations and come up with questions before you can do anything else. An experiment doesn't materialize out of thin air, right? It has to be carefully designed so that it tests exactly what you want it to and gives you meaningful results. A good experimental design is born from your research about the observations you made and scientific questions that came from them. Your hypothesis is another very important component of the overall scientific process. How you phrase your hypothesis determines not only what you study in your experiment, but also how you study it. For example, wanting to know why fertilizer makes plants grow faster is a very different study than wanting to know how much fertilizer will lead to optimal plant growth. The scientific method, which is an iterative step-by-step process that starts with making observations and ends with communicating experimental results, is a lot like a staircase. Each step builds upon the next one, and you can't get to the top without starting from the first step at the bottom. The observations you make lead to scientific questions, which lead to well-formulated hypotheses. These hypotheses guide you in designing your experiments, which, if executed correctly, produce meaningful data that you can share with others. You may be able to jump around to certain steps, say if you need to go back and redesign your experiment. In this case, it's not necessary to start at the very beginning, making new observations, but because your data analysis and conclusions come from your experiment, you'll need to continue the following steps in order. It's in this way that we can see how each step of the scientific method is connected to all the others.